One of the most crucial modes of transportation today is flights, and many companies have settled firmly into their carved-out space in the industry. However, things are about to stop being business as usual, as Boeing introduces a new engine that the CEO boasts will destroy the entire aviation industry. What is this new engine and what does it offer? Stay tuned to find out in this video. Boeing is one of the biggest players in the aviation industry, and if you're a frequent flyer, chances are you've flown in one of the company's aircraft. The company has come a long way since its founding in 1916 by William E. Boeing, a wealthy lumber entrepreneur who studied at Yale University. After seeing an airplane at the Alaska-Yukon Pacific Exposition in Seattle, he became fascinated with airplanes and bought the Heath Shipyard, a wooden boat manufacturing facility at the mouth of the Duwamish River, which would become his first airplane factory. In 1915, Boeing traveled to Los Angeles to learn how to fly from Glenn Martin and purchased a Martin flying birdcage seaplane. The aircraft was transported disassembled by rail to the northeast shore of Lake Union, where Martin's pilot and handyman James Floyd Smith assembled it in a tent hangar. However, the birdcage was damaged and crashed during testing, and when Martin informed Boeing that replacement parts would not become available for months, Boeing realized he could build his own plane in that amount of time. He put the idea to his friend George Conrad Westervelt, a U.S. Navy engineer who agreed to work on an improved design and help build the new airplane called the B&W Seaplane. Boeing made good use of his Duwamish Boat Works and its woodworkers under the direction of Edward Heath, from who he bought it, in fabricating wooden components to be assembled at Lake Union. Westervelt was transferred to the East Coast by the Navy before the plane was finished. However, Boeing hired Wang Su to replace Westervelt's engineering expertise and completed two B&Ws in the lakeside hangar. On June 15, 1916, the B&W took its maiden flight. Seeing the opportunity to be a regular producer of airplanes with the expertise of Mr. Wang, suitable production facilities, and an abundant supply of spruce wood suitable for aircraft, Boeing incorporated his airplane manufacturing business as Pacific Aero Products Co. on July 15, 1916. The B&W airplanes were offered to the U.S. Navy, but they were not interested, and regular production of airplanes wouldn't begin until the U.S. entry into World War I a year later. In 1917, Boeing changed the name to the Boeing Airplane Company. Since then, Boeing has grown into one of the largest aerospace companies in the world. During the last 100 years, humans went from walking on Earth to walking on the moon. They went from riding horses to flying jet planes. With each decade, aviation technology crossed another frontier, and with each crossing, the world changed. And Boeing has been at the forefront of this change and continues to push the boundaries in aerospace technology. And in its long history of designing airplanes, Boeing has incorporated many iconic engines, including the GE90 by General Electric. This pairing by Boeing and General Electric marks an historic milestone in aviation technology. In fact, when we peek into the fascinating mechanics of the Boeing 777 series, the heart that keeps these majestic metal birds aloft is none other than the GE90, the epitome of jet engine innovation. From the moment you first lay eyes on a Boeing 777, one of the most striking features you'll notice is the gigantic GE90 engines. These awe-inspiring beasts, as wide as the fuselage of a Boeing 737, exemplify the engineering marvel that is the GE90. The sheer size of the GE90 allows it to generate a staggering amount of thrust, up to an astounding 115,300 pounds. This incredible power turns the Boeing 777 into an airborne titan that rules the skies. Yet the integration of the GE90 with Boeing's design philosophy transcends the realms of raw power. Boeing, a trailblazer in the world of aviation, saw the GE90 as an opportunity to revolutionize not just engine power, but fuel efficiency as well. The GE90's unique design, characterized by a dual rotor and high bypass ratio and innovative composite fan blades, contributes to an engine design that optimizes fuel usage. When Boeing ingeniously incorporated these engines into the 777 design, they birthed an aircraft that boasted superior fuel economy and significantly reduced operational costs. And the deeper we delve into the design of the G90, the more the marvel shines through. This high-bypass turbofan engine is truly a mechanical titan, featuring technological advancements that make it the heartbeat of long-haul flights. The composite fan blades of the G90, constructed of carbon fiber and a hardened epoxy matrix, are lighter, stronger, and more resistant to wear and tear compared to conventional metallic blades. These 22 fan blades capture and compress incoming air, which is crucial to the engine's prodigious thrust. The high-pressure compressor within the G90 further distinguishes it as an engineering marvel. It has a pressure ratio of an impressive 23:1, the highest in commercial operation. This ratio translates into an engine that effectively compresses the incoming air, generating more power per unit of fuel and elevating the engine's fuel efficiency. The G90 engine also incorporates cutting-edge thermal barrier coatings. These ceramic-based coatings shield the turbine blades from the intense heat produced during combustion, increasing their lifespan and reliability. Moreover, the G90's dual annular combustor reduces the engine's nitrogen oxide emissions by promoting more complete combustion, making it one of the cleanest-burning jet engines in operation today. An essential part of the G90's innovation lies in the Full Authority Digital Engine Control, or FADEC system. This advanced system continually adjusts the engine's performance according to flight conditions. Not only does this optimize fuel consumption, but it also simplifies the workload for pilots and enhances safety. And apart from all this, Boeing's commitment to environmental sustainability is evident in its utilization of the G90. The engine's noise reduction technology, paired with Boeing's thoughtfully designed nacelles and chevrons, results in a significant decrease in noise pollution. This blend of design features makes the Boeing 777 the quietest twin jet in existence, a relief to the ears of passengers and communities residing near airports. Boeing's integration of the G90 engine has enabled airlines to fly the 777 to countless global destinations. Its ETOPS 330 rating was groundbreaking, allowing the 777 to operate routes over large bodies of water and remote areas, making it a preferred choice for airlines. This epitomizes global interconnectivity, reinforcing the bond between continents and cultures. Moreover, the combination of the G90 with the Boeing 777 ushered in a new era of safety. The engine's meticulous engineering, supplemented by Boeing's advanced fly-by-wire technology and multiple redundancy systems, yields a level of safety that is incomparable. In 2002, the world witnessed the G90's unmatched power when a G90-115B model propelled a Boeing 777 to a height of 41,421 feet in a mere 398 seconds, establishing a world record for time to climb in the commercial engines category. This feat exemplifies the engineering brilliance of the G90 and its perfect integration with Boeing's unmatched aircraft design. The integration of the G90 into Boeing's 777 series was a daring move, demonstrating an unrivaled commitment to innovation, safety, efficiency, and sustainability. The powerful blend of Boeing's groundbreaking design and the pioneering G90 engine heralded an awe-inspiring leap in aviation history. This partnership stands as a testament to the remarkable advancements that can be achieved when industry giants collaborate to redefine technological boundaries, emphasizing efficiency and sustainability. Now, another iconic engine, the Trent 800 by Rolls-Royce, undoubtedly marked a significant milestone in the world of aviation. According to industry experts, Boeing took a visionary leap by incorporating this powerhouse into their plane designs, notably the magnificent Boeing 777, turning it into a feat of aeronautical engineering. Brought to life by the engineering prowess of Rolls-Royce, the Trent 800 truly exemplifies strength and reliability. With a staggering fan diameter of 2.79 meters, it is specifically designed to generate an incredible thrust range of 75,000 to 95,000 pound force. This means the Trent 800 can produce a force equivalent to the weight of approximately 43 small cars, creating enough push to get the colossal Boeing 777 off the ground. The fact that Boeing sought it fit to utilize this power within its own creation speaks volumes about its trust in the Trent 800. And the marvel doesn't stop there. The Trent 800's efficiency is another impressive detail. The engine boasts an impressive bypass ratio of up to 6.5 to 1. In simpler terms, this indicates the majority of the air pushed by the engine's fan bypasses the combustion process, providing more thrust with a lesser fuel consumption. Consequently, it contributes to a reduction in operating costs and environmental impact, a detail that beautifully syncs with Boeing's commitment to sustainability and efficiency. And Boeing was careful to factor in the impressive power-to-weight ratio of the Trent 800 as well. With a dry weight of only 6,246 kilograms, it delivers an excellent thrust-to-weight ratio, something crucial for a long-haul twin-engine aircraft like the 777. This meticulous integration led to improved performance, longer ranges, and an overall improvement in fuel efficiency, contributing to a markedly better passenger experience. Rolls-Royce's Trent 800 incorporates three-shaft architecture, meaning it consists of three independent rotating components: the fan, the intermediate pressure section, and the high-pressure section. This ingenious design minimizes the mechanical stress on the engine and significantly reduces the weight. When Boeing decided to integrate this engine into its designs, it meant that the aircraft would not only gain unparalleled propulsion, but also increased reliability and efficiency. And Boeing also exploited the Trent 800's advanced noise reduction technologies to produce quieter planes. Thanks to the engine's wide-chord fan blades and innovative noise insulation materials, the 777 was able to offer a more comfortable and quieter cabin experience, a remarkable achievement considering the sheer power generated by these engines. Moreover, the plug-and-play modularity of the Trent 800 was a godsend for Boeing's design strategy. The engine is built in modules, which enables easy and quick maintenance, minimizing downtime. This approach allowed Boeing to provide an aircraft that could be readily serviced and returned to the skies as swiftly as possible, ensuring high operational availability. Also, Rolls-Royce has an innovative solution called the Engine Health Management System incorporated into the Trent 800. This system uses data from sensors throughout the engine to predict maintenance requirements, improve efficiency, and avoid unnecessary servicing. By incorporating this engine, Boeing managed to enhance the operational life of its planes and offer a significant reduction in maintenance costs. The incorporation of the Rolls-Royce Trent 800 engine into Boeing's aircraft design was not just a marriage of two titan brands, it was a fusion of innovation, foresight, and engineering prowess. It enabled Boeing to offer aircraft that had increased fuel efficiency, better range, improved noise reduction, and importantly, a superior passenger experience. All in all, it showcased a phenomenal blend of power, precision, and performance, making Boeing planes not just an engineering marvel, but also a testimony to human ingenuity. Boeing, however, is not resting on its laurels as it continues to form crucial collaborations with engine developers. And one of its partnerships with its CFM International promises to change the future of aviation with a radical new engine design that could power the next generation of airplanes in the mid to late 2030s. The new engine, called RISE, or Revolutionary Innovation for Sustainable Engines, has an open fan that would change the look of airplanes and provide deep cuts to carbon emissions. The RISE engine is based on a concept that CFM International, a joint venture between GE and French engine maker Safran, has been developing for several years. The engine has a giant open fan at the front that's not enclosed by a pod or nacelle like today's engines. This allows a much bigger fan diameter that can generate much more thrust and substantially better fuel efficiency. The fan blades can also change their pitch and adjust the airflow, as can a set of fixed vanes just behind the fan. These vanes can also serve as a brake by blocking the airstream when the pilot lands. The RISE engine also has a tiny engine core similar to that of a small business jet engine. The core is where the air is sucked in, compressed, ignited, and blown out the back. GE and Safran have used advanced supercomputers to design every aspect of the core, including the advanced materials and additive manufacturing processes used to make intricate inner nozzles and cooling paths. Another striking aspect of the RISE engine is its hybrid electric capability. On today's airplanes, the fan that spins the central shaft generates electricity used to power various systems on the aircraft. On the RISE engine, that electricity will also be used at times to help turn the shaft. This means that when the engine is running on electricity, it's not using fuel. This is a brand new concept for added fuel efficiency and lower emissions. Boeing and CFM International are each helping with tests of different aspects of the RISE engine. Boeing will test fly the hybrid electric aspect of the engine on a Saab 340 turboprop around mid-decade. CFM International plans to test fly the open fan aspect of the engine on one of its A380 Super Jumbo jets around the same time, and GE and Safran are already building and testing hardware components for the engine. The RISE engine is expected to offer significant advantages over today's engines. It could reduce fuel burn by more than 20%, lower noise by 25%, and cut CO2 emissions by 25%. It could also save about a ton of weight on each engine by doing away with the heavy nacelle pod and the internal thrust reverser. The RISE engine is an exciting and revolutionary innovation that could transform the future of aviation. It could enable Boeing to build more efficient, sustainable, and competitive airplanes that meet the demands of customers and regulators. It could also help Boeing regain its leadership position in the aerospace industry after the challenges it faced with the 737 MAX. The RISE engine is not just an improvement but a game changer for both Boeing and CFM International.